How are you? Right, I'm going to talk today about Node.js and give you an introduction to Node.js and what it actually is. So, what is actually Node.js used for? Right, let's just get enterprise software development out the way as it's 10 a.m. in the morning. But in enterprise software development, Node.js is commonly used for microservices, so such as kind of like REST APIs, message queues, full stack applications, so from the back end all the way to the front end, mobile applications, some mobile applications are developed in Node.js as well, Internet of Things, and desktop clients as well, using kind of frameworks like Electron. What about the startups and hackers? Well, startups and hackers are kind of using command line interfaces or building command line interfaces, like Zip. They are using P2P media, such as IPFS. They're controlling robots, Bitcoin or any other cryptocurrency, torrents, databases, and loads of other things as well. So kind of possibilities are endless with it. It's about sounding cliche. So, so how was Node.js designed to be better than kind of like the current web servers and kind of frameworks around 2009 when it was introduced? Well, it was designed to be scalable. Well, sorry, let's start again. It's designed to build scalable network applications in JavaScript. You might be wondering why in JavaScript. Well, everyone has seen JavaScript. The web's powered by JavaScript, and it's quite a low barrier to entry, like something like C++, which is quite difficult to grasp. So Node.js uses an event-driven architecture. It took the best ideas from Python's Twisted and Ruby's event machine. What that means is, in essence, when our code executes, we push claims or callbacks or functions onto a queue in this event loop. And then as this event loop ticks round and round and round, we basically pick off the functions that we need and execute them at some point in the future, allowing us to do kind of I/O and reading from network or writing to disk or reading from disk without having to block other things that are going on at the same time. So let's dive into a little bit more into that. It's also known as like a single-threaded event loop. So it's a single thread going round and round. So no one piece of code will execute twice at the same time. However, technically Node.js does use multiple threads underneath, but your code will run in a single thread. So let's take a look at this Hello World application on one screen, okay, on two screens. And so in this Hello World applications, we can accept many connections at the same time concurrently. So this callback here, this is a function or a callback. This gets called on every connection to this web server. So if you have multiple users, let's say everyone in here is connecting to this single web server at the same time, it'll be able to handle each one of you by looping through this event loop and basically firing your own callback whenever you visit the website. And as that loop goes round and round, it takes more and more callbacks, often dispatches them, and in this case, sends Hello World back over the wire to you. So let's go deeper into this, how it actually works. So Node.js uses something called libuv underneath to handle asynchronous I/O. That's input-output operations like accessing the disk, accessing the network, and it basically means that we can execute our code without having extended periods of time where it's blocked. What that means is that we can kind of handle all of these connections coming into our web server, but also read from file, write to a file, read from a database, write to a database, at the same time as handling other connections. Not at the exact same time, but within the same event loop. So we can kind of continuously handle multiple pieces of I/O and connections at the same time. It's also backed by V8, which is Google's JavaScript engine that's found in Google Chrome. What that means is that the actual parsing, compiling, and execution of the JavaScript is actually handled by V8 or Google Chrome. There's also other backends, like something called Chakra Core, which basically allows you to use Microsoft Edge's browser's JavaScript engine. But we're going to kind of just focus on the standard, which is V8. Cool, so the actual event loop itself. So I was talking earlier about how you have this event loop that ticks around and you handle these callbacks as it goes round and round. This is it's a 7-stage process, or 8-stage if you care about the internals, but we'll focus on the 7 here. So you've got timers, IO callbacks, etc., etc. And I'll go into detail what these are. So each one of these things is a phase. It has a first in, first out queue of callbacks to execute. So any callbacks that go in come out first. While each phase is special in its own way, generally when the event loop enters a given phase, it will perform any operation specific to that phase, and then executes all of the callbacks in that queue, or the phases queue, until it's been exhausted. So it will execute all of the callbacks, and then it will move on to the next phase, and so on, and so on. So let's see what each individual phase does. So timers, this is the first phase, if you will. It executes the callbacks scheduled by set timeout and set interval. So these are the kind of scheduling things that happen in a certain amount of time later, like set timeout 10 seconds, and your callback will fire in 10 seconds. Or set interval and have something run every second. For example, echoing out hello Doge to the console every second if you really fancied that. The next thing is the IO callbacks, and this executes pretty much almost all of the other callbacks apart from three main ones. Close callbacks, which we'll get to right at the end. The one scheduled by timer, and this special thing called set immediate. This function basically allows you to control where your callbacks get handled, but we won't go into that. So when we hit this these IO callbacks, this is when our actual callback here is being fired, because we've got information on the wire from the network saying that we have a connection and that they've sent a request to our server. This has already been queued up, and we fire this listen event, and we send the data back. The next two steps are basically internal only. We can just ignore them. The one after that is poll. This is when we actually retrieve new IO events. So this is where we actually schedule the events that will be like receiving more and more data. And this is where you would generally block more and more. So if you're reading from a WARC file, or you're reading from network connection, etc., when the data is actually being processed, you will block at this stage. So let's just look at this again. So we have the incoming connections, i.e. the data, etc. That goes through two things that we haven't talked about yet. We handle the timers. We then handle any of the IO callbacks, and then we poll for more data, etc., etc. Second from last is check, which is set immediate callbacks are invoked there, so that's when they're actually called. And our close callbacks, and these are when we're kind of closing a network connection or a disk connection, or disk resource. You don't really need to know all of this, but it gives you a really good idea on kind of like how this actually works, and it will help you understand Node.js is kind of asynchronous nature, and how it's actually very different to kind of, let's say, C, where you're just running through for loops and it's very procedural. You're actually dispatching callbacks at certain points of time, and these can happen at different times based on this event loop. So let's just kind of recap what actually happens in this, because although it's very simple, there's a lot of things going on underneath. So we require our HTTP module, and this is kind of a built-in module inside of Node. We define two constants or two variables, which are assigned 127 to our local host, a port number. Then we define the server, we create a server, and this has a callback which is invoked not at that point in time, but whenever we get a new connection. And so that just basically stays there but doesn't actually happen. And number two, we have a command which basically says listen on the port and host name that we have. So we actually set up the connection, set up the listener for the server, and then fire this callback when we actually we actually have a server up and running. So what would print out is your server is up and running at HTTP localhost port 3000, and then whenever I make a request, you're going to start seeing data coming into this. I'll try and give a demo later on, but we're going to move through to the next big thing about Node.js, which is modules. And for me, it's one of the best features of Node.js, having modules. What are modules? They're isolated pieces of code, which allows you to kind of reuse and deploy and basically allow other people to reuse. So a basic Node.js module is, it basically uses this kind of AMD pattern, automatic module description, which basically allows you to export a function. So in this case, we do use module.exports. This basically says this module will provide this interface. We basically assign that to a function, which will return 42. And then in our second file, we can require that file. So this is, the top one is answer.js. The bottom one is requiring this file, assigning it to a variable, and then calling that, which returns 42. So we kind of have a module there, which is good. I mean, it's a very basic module, but at least it's something, it's ours. But what happens if someone else wants to use my module? What happens if you want to kind of pull out number 42 and use it in your code base? Or what happens if I want to use a module that you've written which returns 37, let's say, which was built by somebody else? So you can use a thing called npm. Now, npm is originally known as the Node package manager, but it's kind of moved away from that, and it's kind of a JavaScript package manager now. That's the cute little logo. It's a brilliant resource. It's a module repository. It contains so many modules, and we're talking hundreds of thousands of modules. It's a brilliant resource for finding things. It can be a bit overwhelming. However, we'll go through some default modules which you can kind of get yourself going with on it. We can publish our own modules to this repository whenever we want. We just follow the above commands. We do npm login in our command line once we've got npm and Node installed. npm comes with Node by default, so you only need to install Node. You then do npm init, and that basically sets up your module to basically be ready to be published. And then you can just run npm publish. And it's as easy as that. Once you have that published and you verified it's worked, you can basically just do an npm install my module and start using it. It's great. And maybe someone else can as well. And the only difference is, well, there's no difference. You basically just require your module, and then you get more answers, which is 37 in this case. So you can see the slight differences between that. We have the top one, which is requiring it from npm, which is still accessing the local module directory on your machine. However, you don't use this / syntax, because the / is basically saying, I want to require this file. It's a bit elusive sometimes, but there's a slight distinction. But yeah, just require my module, and you can require my module, and everyone can get 42 or 37 back. So I've published my module, but now I really want to start using other people's modules as well, so I can speed up my development. But how do I actually find these modules to use? So to start building an API, for example, a good step is choosing a framework to use as a building block, something to get me started, something that is opinionated and will guide me through how to actually build something in a certain way. These are usually a lot larger than just normal standalone modules like my module that returns 42, but they provide something to kind of guide you in making something a lot easier. For example, we have a list of kind of 4 main web application frameworks: Happy, Express, Rustify, and Cur. Now, we'll get into which ones I like in a bit, but if you could pick any of these 4, well, top 3 mainly, but 4th one if you really fancy. They're all pretty solid things to use and have a lot of decent documentation, which you can kind of start looking through. It's very good to kind of use something that is, a lot of people are using, because there's a lot of community support in that. The next big thing for me is testing frameworks, being able to test your code as well. Ava is one of my favorite at the moment because it allows, well, it basically forces all my tests to run in parallel, which means that each individual test has to be isolated and not be dependent on each other, which is one of the big things you get with a lot of testing libraries. People write their tests so they depend on each other. So when you separate those out, all of your tests break. So small isolated tests are great. We can also do things around robotics and IoT platforms as well if you fancy. It's not really, it's really part of the web as well. You can kind of control hardware from your web browser. You can control internet IP cameras from your website, or you can send peer-to-peer video between between multiple computers in your house, all using web APIs and using Node.js in the back end to facilitate all of this happening. You can also kind of play around with robots or flash even small ARM chips if you really fancy. So what to actually use? So it kind of depends on the use case, really. If you're building RESTful microservices, there's kind of two big things which I would kind of usually ship between the two. I'd either go for Restify or Happy. I usually go to Happy due to the bigger collection of community plugins in place. It seems a bit more, there's a lot more community support around it at the moment. But sometimes I choose Restify if I need traceability into all of my requests, audit logs, things which the business really requires, or the pure performance of my APIs. And it was maintained by Netflix at some point as well. It might still be maintained by Netflix as well. Web servers, again, you have Happy. You could also got the choice of Express, which was one of the first frameworks and is still extremely relevant now. And you have Core as well, which uses a lot of new features of JavaScript. I tend to still would go for Happy. This is only because I tend to write APIs and web servers within the same kind of lifespan that company. And I usually try not to mix and around frameworks when I'm developing multiple projects, because jumping between one framework and another can be a bit confusing when you've got 20 microservices plus 2 web servers to handle. So by keeping everything the same, it makes it a little bit easier. However, if I was serving isomorphic React and Angular applications, then I'd probably use Express, just because there's a big community around Express. There's a lot of support, and it's still the go-to web framework for a lot of people. Testing frameworks. Tape is my go-to, but it's very, very difficult to get used to. It's very different from everything else that's out there. So I'd probably say use Ava. It's still extremely nice, and it's very much like a lot of the other testing frameworks that are out there as well. So once we've decided on the framework that we want to build, let's say I'm using Happy to build an API plus a server to return some static site content. We also need to kind of have help on handling data and inputs with, let's say I'm talking to an external API and their JSON response that they come back over the network is a bit too complicated for me. I want to kind of change this object that they're giving me to something a lot more simpler and something that I can use without having to do a lot of computation and kind of data munging to get it all working. So I tend to use a lot of modular utilities, and don't be afraid on using other people's code, because it's usually much more well tested and a lot more people have used it, so you know it's actually pretty okay. So for example, there's this module called async. Now async has this thing called async map, which allows you to run a like a map over over an array. So in this case, we run over an array of file names, which we call the function fs.stat, which gives us the syscall stat information of that file. What this means is that we can actually call all of these at the same time, and then whenever they come back, we don't care, put them into an array, and we get the results in this callback at some point in the future. So the results in that point is now an array of stat objects. If you were going to write this normally, you would have to kind of have a callback, and another callback, and another callback, and then somehow kind of link all of those callbacks together to get a result at some point in the future, and it gets very complicated very quickly. The same as like if you wanted to do, let's say, async parallel, running those two functions in parallel, but also having a response at the end of those two callbacks, and also running them in series as well. So you can kind of, there's a lot of constructs that you can kind of build up and use with modules to run callbacks in a certain way. And these modules help you a lot. There hasn't been a single project that I've used that hasn't actually touched async or some kind of asynchronous flow control. So I would definitely use these if you can. Some more kind of modules, there's things called Lodash, which is basically how it allows you to handle objects and kind of filter through objects, iterate over objects, etc. Lodash FP, if you like functional programming, you'll know what it is. Ramda.js, which is the same kind of thing, allows you kind of to do functional programming in JavaScript. You can use async await, which is a new feature in JavaScript, which allows you to run your code as if it was synchronous, but it still be asynchronous. You can use promises or any of the new features inside of JavaScript as well. So this Lodash thing, it provides these amazing things. So you can kind of have this array of users coming back from our async map on our stat object, which gives us a load of users. And we can filter based on any of the active users, etc., and just get a single object back. So there's a lot of helpers around this, which saves you from writing loads and loads of code. Because programmers are lazy, and they don't want to write loads of code. They want to write something that's extremely concise, works, and does the job. But no choice is the right choice. Just remember that. The choices can be hard, but as long as the software is still supported, it's kept up to date with security patches, and other people kind of find it easy to use or understand, then you know you won't really have many problems. And it's finding kind of a middle ground between choosing what module to use. So just remember it depends on the situation and also the team that you're working with as well. Now I'm just going to talk about a couple of things which I think is really important when just developing software in general. Testing. Test creates a feedback loop that informs the developer when the product is working or not. And the ideal feedback loop is as fast as possible. No developer wants to wait hours or days to find out if their change works. Sometimes the change doesn't work. Nobody is perfect. The feedback loop needs to run multiple times as well. So a faster feedback loop tends to lead to faster fixes. If the loop is fast enough, developers may even run tests before kind of checking in or committing any changes to your source control. It's reliable. No developer wants to spend hours debugging a test, only find out that it was a flaky test. Flaky tests reduce the developer's trust in the test, and as a result, flaky tests are often ignored. So even though they sometimes find real problems, they can be totally ignored because they have been flaky in the past. It also isolates failures. So to fix a bug, developer needs to find specific lines of code causing the bug. When a product contains millions and millions of lines of code, the bug literally could be anywhere. So it's like trying to find a needle in a haystack. So the idea is to kind of write unit tests, like the majority of your stuff, unit tests, testing components in isolation, that they behave as we expect. Then not as many integration tests, so test subsystems work together as expected. In that case, that could be multiple different parts, multiple different modules speaking to each other. And then system test that your web server returns hello world or not. And as you go up that pyramid, it increases the cost to produce and to repeat all of those tests. You also would probably want to use some kind of continuous testing framework or service. This is often referred to as continuous integration or continuous deployment. Use something like Travis, which is free for open source software. Jenkins, if you if you want to run it yourself, or Circle CI, if you want to pay for it. A lot of them have, Travis and Circle CI, I believe, have student plans as well. But they're generally free, so you just use them, test your code on every commit, and make sure that what you do actually works. Follow coding standards. You want to make sure that the code that you write is easily readable by your peers and by other random people as well, especially when you're working on modules which you're exposing to other people. Sometimes I find it really difficult to read other people's code, and I rely on using something like ESLint, standard.js, or semi-standard. This basically tells you if you have any syntax errors, catches certain errors first, and basically makes your life a lot easier. They also come with kind of a fixed parameter as well, which you can actually automatically format your code if that's your jam as well. And the last kind of thing is you can also, if you want to learn more and kind of teach yourself more about Node, is utilize all the resources out there. So there's this thing called Node School, which is a set of tutorials that you can run on your machine. You can run alone. You can run them alone, or you can find out any kind of meetups that are happening in like a city where you are. There's a few in London. I'm not sure when the next one is, but you can basically either go to that and start learning in a group. You can go to that if you feel comfortable enough to teach, because I find the best way of learning is by teaching. And then you can also just do the tutorials on the actual website itself at home, if that's really what you prefer as well. So I'm Tom Gallacher, thank you for listening. If you have any questions, please let me know. I work for Wildy. Yes, so any questions, please, and I would answer anything. I understand it's a Monday. Wednesday. It's Wednesday.
I have a question.
Yes.
So if I hadn't used Node before, and I
Yep.
want to start off on my machine to write something simple,
Sure.
how do I start?
I will show you. Cool. So let's do a bit of interactivity in. Wait, where is it? Over here. Cool. Can everyone read that? Okay. Yes. Right. So the most simplest way would be to create a new folder. So I create a folder called Node.js something. In here, I have. Oh, let's go into there. You've seen all my projects. No. So I have nothing in this directory. So the first thing that I would do, I would usually run npm init and create a new module. And this is what I was showing earlier. You can create a new module as easy as this. So it autofills in your package name, yes, version, description, entry point, which is the file that runs, a test command, let's say ava test /index.js. Git repository, I won't have a Git repository for now. Don't need a keyword. Author, doesn't matter at the moment. And a license, I'm going to use that license. I think it's okay. So I now have a bare bones Node.js project. That is a bare bones Node.js project, just a package.json. Now, this package.json is just a JSON object which contains everything that I just typed in there, but in an easily readable form. And what this means is that when I publish it, it basically informs the package manager how to run your code. So the next thing is actually writing your application. So let's go to vim index.js. So let's create this file. Oh, this is weird typing like this. Const hello equals 42. So then I will have I'll expose a module, sports, which returns a function, like in my example, if I can type. God, I'm usually much better typer than this. And then let this actually return 42. Well, let's let it return hello even. So this is my bare bone module now. So I can then write a test for this. So we write a test / index.js, and then we can kind of have a look at the examples of Ava online. So I tend to spend a lot of my time kind of searching for how the frameworks actually work. So the best thing with that is kind of search for Ava on GitHub in this example, and then start reading the README. So I can never remember how things work. I always have to reread the README, kind of look at the usage. So it says, right, first thing I need to do is install Ava globally. So I'm going to do that right now. Oh, I'm not using Vim. So I'm going to just install Ava globally. So this will install it globally, and then while that's happening in the background, we will see that our package.json will update to have this thing called dev dependencies Ava, with this scripts test Ava section in our actual application. This is after we've run Ava in it, so it's quite a simple procedure. So once that is done, we can then create our test file, which we use this here. oops, I need to actually have the right permissions to do that. Don't type my password in the screen. Lovely. Should we faster? So yeah, npm is usually, there's the latest release which makes it quite fast now. It's quite a big package, but you can see it's now kind of installing Ava as a command line tool. So I can do Ava version now, and I can see, well, no, I don't want it to be Java. You can see it's now got a version number now. My computer thinks it's Java. How embarrassing. So then I run Ava init on this. This is what the README was telling me to do. This basically just sets up my my environment to run the test as required. This usually takes it's a lot quicker than this usually. So yeah, just a kind of like an example of a test here is you import test from Ava. This is the same as the require syntax, but it's a new JavaScript syntax that you probably see on kind of the Angular React talks. Node.js doesn't kind of have this syntax yet, so Ava is kind of a bit special in this. We then define a test, we call it foo, and then we just make sure that our test here passes. And then the next thing here is we can kind of make sure that our asynchronous test, so this is using the async await syntax, returns bar at some point in the future. And this is all asynchronous. So if we go back to this here, we now should have everything. We should look at our package.json. We now have our dev dependencies, Ava in there. We have our scripts, test Ava, test index in there. So then we can bring back our window, copy in all of this piece of code here. Have that code in there now. Ooh, it doesn't exist. Okay, that's fine. I need to create a directory first. Cool, we'll have that in there. So npm run test now. We can see Ava's running our test, and now we have 2 passing tests. Although these don't actually mean anything, so let's make our actual test worthwhile. So this can easily just be as easy as adding test function, name of it. We have 42. We then have a t, which is a function in this bracket here. And then we can kind of say const module equals require, let's go upper directory, because that's where it is, and it's index.js. So we require that, and then we make sure t dot is, so we expect this function to return 42. So we call module, put 42 there. So we say t, well, module's a reserved word actually. Hello. Hell is 42. So we run a test and we should get 3 passes now. Ta-da. So how can we confirm that's right? Well, usually I write a wrong test first. So I would usually write my test first, it would fail, and then I'll write my application to actually fulfill this contract. But just to confirm and show you that it's working, we change that to 41, run the test again, and then I should get a failure now. Yep. So 41 must be strictly so 42 must be strictly equal to 42. So you can see it shows the line which is failing in the test. Very nice. Can help you learn everything. So that's just a basic module. Let's actually, I'm going to actually show you, like you can actually publish it as well. So let's publish this module. So this is publishing this module Node.js something. Now that, if we go into npm.org and look for, this is npm, don't be afraid to use it. So what do we call it? Something Node.js. Was it Node.js something? Node.js something. Something. So we see Node.js something there at version 0, which should be deployed by me. Yep, that's me there. So you can just publish it whenever you want, and increase the version when you want it to. And then anyone, like you could now just go on your computer, install Node, do npm install Node.js something, require that module, and get 42 back. And it's as simple as that, really. Don't be afraid to use it. And the same as like using Express or Happy, go onto their website. There's a simple kind of like how-to of like getting up a basic server up and running. And from there, once you kind of start playing around with all these libraries, which kind of the talks kind of shown you, you can kind of add things together, construct new ideas, and kind of just develop on that. And yeah. Does anyone else have any questions or thoughts? Hi.
So you mentioned using Node Express. Is
Yes.
there any other like sort of frameworks and stuff you use in like a full stack application?
So for a full stack application, I would usually just use Express because there's a lot of there's just a lot of modules around kind of that whole ecosystem in kind of bundling up assets, bundling up your client and server side JavaScript, and kind of returning that to the user as well. There are kind of like MVC frameworks like Sales.js and Ember, which basically allows you to kind of do the whole full stack thing in one go. I tend to not use those things because of the work that I do. I usually work at kind of larger corporations, so they like having small discrete services for each individual thing and building something specific for a specific need. But there's no kind of right or wrong thing. My personal preference is Express for that kind of scenario. Yeah. Anyone else? Don't be afraid. Is there anything that anyone would like me to demo as well? I can quickly.
So you demo just like making the simplest thing that shows something in the browser.
Yeah.
Like, just hello world.
Sure. Let's use it. I'm gonna actually take the content from my slide, wherever it is. Let me just. Where's my mouse? There we go. Right. It's gonna be a bit of a mystery for a second. Right. So I'm just going to pull out the example of our HTTP server from the Node.js website. Yeah, full screen. So the most simplest web browser is in the docs. Well, let's actually. Cool. Let's go to Express. JS. Oops. Not the Daily Express. So this is Express.js's website. It's not that easy to use, is it? Right. Get inside. Install it. So we've created our directory, we've done npm init, we specified our entry point. So the next thing that we're going to do is install save. So we do npm install express and save, so that saves it to our package.json. So let's actually do this now. So that will install express and all of its dependencies, save it to the package.json. So you can see now that the package.json has not a dev dependencies object, but a dependencies object, which is basically just Express. What that means is that when you actually install it in production, only Express will be installed in your testing framework, won't in the background, kind of to minimize the size of your package. So the next thing is now, well, that's the end of that guide, and then we go on to the hello world here. So the most simple Express application is this here, which let's put this inside of our module. So inside index.js, let's remove everything in here. So this now is not a module that's going to be used by other people. It's a module. It's just a application to run our code. So in here we've pasted in our Express server. So this looks extremely familiar to kind of the example I was showing you in my slides. Now the only difference is instead of returning on every connection with certain things, we now have this concept of a HTTP URL router, and that's what this command, these 3 lines under here show. What that means is when you go to / in your browser on port 3000, you send back hello world. So let's give this a go and walk through it. So we require Express. We instantiate Express and assign it to app. We then define a HTTP GET method on the URL /, which calls this function, which we get request and response objects back, and then we send the response hello world. And this is the same thing. We then listen to this. We make the server listen on port 3000. And this time we were excluding kind of the host 127.0.0.1. We're just basically saying listen on all interfaces on this machine on port 3000. And when that's actually up and running, we get this console.log happening. So let's actually run this. So we save this, quit this. So when they run it, we just do node index.js. Our app is now running on port 3000. It's quick. And now we can kind of go 127.0.0.1 port 3000. And we get hello world coming back. So let's say we want to actually now modify this to send a different URL parameter back. So let's say I want to have an admin page that says access denied. So let's just go to here. We still want to do a HTTP GET. We can say admin. We can send this here, access. Denied. But we can also do res.status code 403. I think it's been a while since I did Express. Save that, run it again, and hopefully it works. If it doesn't, you can see Express crashing. So we've got hello world there, and we get to admin, and we get a failure. And this is a failure that happened because status code doesn't actually exist. I've used the wrong function, and here I'm now getting a stack trace coming back. I did this on purpose, obviously. It shows me where the stack trace is actually happening and what the line of code is at fault. So I can see that Node.js something index at line 9 has thrown an error saying res.status code is not a function. Okay, okay, right, it's not a function. I also see that in my terminal here. It's exactly the same thing. So let's actually fix this now. Oops. Turn that. But how do I actually fix this? So I'd usually now look through the API reference for the latest version, search for status, and there we go. We can see that we actually do res.status, the status code, and then send something after that. So let's adjust our code to do this. So stuck in the old days, status, call it 403. We can now chain this on, so we can just remove this. So this is now chaining on. This is the same as doing res.status and res.send, but because the interface is chainable, you can kind of do res.status 403 send access to node. We need to actually run our code. So that's running again. Then go back to our local host 3000. And go to admin. See access denied now, which is great. And now if we have a look in our web browser console and go to the network tab and give it a refresh, we should see that it's a 403. We can see there it's a 403. And that's basically the most simplest of web servers that you can build. And I think if I have a load testing tool built in, I can artillery quick. So this is a a load testing tool built in Node.js. So we're going to quickly run it against localhost. If I can type it right. And see what it can actually do. Oh. Just to show you that it can handle more than one request at the same time. So that's not nothing quick. So if you do quick and then the URL, arrival rate must be specified, which is, oh, this is difficult to read. Let's put that over there. Can't read it. Just, it works. Yeah, it can handle multiple concurrent connections, so if all of you were going onto this page at the same time, you can refresh this loads and loads and loads and loads, and it just works. It can handle multiple connections at the same time. If this was a PHP script, for example, you would need to have kind of something like Apache in front of it to go through, and then Apache would be spinning up an individual PHP process in the background to handle each of those users. So this is just a single application running. And to give some unsubstantiated claims, it can handle about like 2,000 to 3,000 requests a second on just one core on my computer, for example. So it's pretty speedy.
Cool. Okay, well maybe we should stop there. Let's thank Tom. We'll take about a 10-minute break before the next talk. I'm sure if you want to come and grab Tom at the front and ask
please do.
questions.